Have you ever wondered what stuff is made of? How do you picture an atom in your mind? Like this, or maybe one of this? Here in PISAYY, we always have something to say. Let us all answer some of your questions regarding this matter. In order for us to get our answers to our questions, we need to go back thousands of years to when scientists get the theories of development of an atom.
But first, do you know the man who first thought about the concept atom is Democritus? Yes, Democritus. He believed that everything in the universe was made of tiny indivisible particles which he called atomos, meaning uncuttable. His idea was that if you keep dividing matter into smaller particles, you eventually reach something so small it could divide any further. So, are you curious about what happened next? Today, we asked our guests to give us a better understanding of how they come up with this kind of theory. Let us all hear it together with our host and our guest scientists.
Good day everyone and welcome to PISAYY. I'm Mira Gabilagin and this is a talk show that takes you through the fascinating journey of the atomic theory. Today we have a lineup of extraordinary guests who play crucial roles in shaping our understanding of atom. A while ago, we heard that Democritus is the man who first drew about the concept of the atom. But what came for that? Let's bring out the man who took Democritus' idea to the next level. Please welcome Dalton. John, you're known as the father of modern atomic theory. How did you build on Democritus' idea?
Indeed, I took Democritus' concept and gave it a scientific basis. In the early 80s, I proposed that atoms of different elements have different weights and combine in specific ratios to form compounds. This was the first step towards understanding chemical reactions at the atomic level.
And what a leap that was, but things did stop there. Let's welcome the scientist who discovered something within the atom itself, J.J. Thomson. J.J., you're famous for discovering the electron. How did that change our understanding of the atom?
Thank you. Yes, in 1897, I discovered that atoms weren't indivisible after all. They contain smaller, negatively charged particles called electrons. I proposed the Plum padding model where electrons were scattered within a padding of positive charge.
But of course, that model did last long, did it? The man who gave us the nuclear model of atom, Ernest Rutherford. Ernest, you conducted the famous Goldfarb experiment. What did you discover?
Indeed, in 1911, I found out that most of the atom's mass is concentrated in a small, dense nucleus at the center, with electrons orbiting around it. This overturned Thomson's model and led to the nucleus of the modern atom.
Revolutionary to say the least, and to wrap up our atomic journey, let's bring out Niels Brock. Niels, your old model, something critical to record, so what is it?
Thank you. It's a pleasure to be here in 1913. I proposed a model of atomic structure that describes the atom as having a small positively charged nucleus as its center, with electrons traveling in circular orbits around this nucleus, much like planets orbiting the sun in our solar system. The force that keeps the electrons in this orbits is the electrostatic attraction between the positively charged nucleus and the negatively charged electrons. This became known as the Bohr atomic model.
And just when we thought we had a clear picture of the atom, things got even more interesting. Let's welcome to the physicist who introduced us to wave mechanics and probability in atomic work, Erwin Schrodinger. Erwin, your work brought us a new perspective to our understanding of the atom. Can you tell us about it?
Finally, in 1926, I developed a mathematical equation now known as the Schrödinger equation that describes how the quantum state of physical system change over time. Unlike the Bohr model, which had electrons orbiting in fixed paths, my model treated electron as a wave function, showing that their position around the nucleus is a matter of probability rather than certainty.
So instead, fixed orbits, electron exit in blocks of probability around the nucleus.
Exactly. My model suggests that we can only predict where an electron is likely to be, rather than knowing its exact position. This was a key development in quantum mechanics and it changed the way we view in the atomic world.
What an incredible journey from the divisible particles to complex atomic models. Our understanding of the atom has come a long way. Let's give a round of applause to our distinguished guests.
And there you have it, an incredible journey through the evolution of atomic theory. From the earliest ideas of invisible particles with Democritus to Dalton's solid spheres, to the discovery of electrons by Thomson, and the revolutionary insights of Rutherford and Bohr, who gave us the nucleus and the quantum leaps of electrons. Each of these brilliant minds shaped the way we understand the very fabric of matter. Thank you for joining on this journey through time and science. Until the next great discovery, stay curious, keep questioning, and never stop exploring the wonders of the world around us.